Number 4, I can see I can factor out an x squared, so I'm going to take out that GCF of x squared. And now I have a trinomial, and I know how to factor that because that's a pretty easy one to factor. I look for my factors of negative 12 that add up to negative 1. So that sounds like it's going to be x minus 4 and x plus 3. Now, if you're not very good at factoring, this is going to be hard. You have to be good at factoring. So if you were kind of hoping to forget all that, I'm sorry, you can't forget all of it. It's really important. So our factored form, we have g of x is equal to x squared times x minus 4 times x plus 3. Okay, that means our zeros is we have 1 at 0, 1 at positive 4, and 1 at negative 3. The 0 has a second power, so it's going to bounce, and these are both through. So if I go to my axis, I have to get up to 4. So 1, 2, 3, 4. I have 1 at positive 4, I have 1 at negative 3, and I have 1 at 0. I need to think about my end behavior. It is a positive x to the 4th. Positive x to the 4th is this W shape. That means they're both going up to positive infinity. That means I'm going to have one arrow up this way and another arrow up this way. Now I just have to connect everything. It goes through and then bounce and then through. So I'm going to go through, bounce, through, and I got it. Okay. Number 5 is a little bit different on the factoring because I don't have a GCF, but it has 4 terms, so I can do factor by grouping. That's what I'm going to do. I'm going to factor this by grouping, and you might actually need a piece of scratch paper or something. I might end up using extra paper. We'll see. See how much space we need. Okay, I decided I didn't need more space. So here's what I had started on the other page, but just so I have more space, I put it over here. For the factoring by grouping, that's a new one for this unit. I know that I have to take out my GCF here, which is going to be x plus 3, and take out a negative 4 of my GCF here, which is going to be x plus 3. The x plus 3's do match up. Good, they're supposed to. That means the x plus 3 is like the GCF of this whole thing. And then I have x squared minus 4 over here. I know that x squared minus 4 is a difference of squares. That means a perfect square minus a perfect square. And that can be factored to x plus 2, x minus 2. Okay, here's my factored form. So I'm about to go back to my paper and put this onto my factored form. Okay, so I wrote down my factored form. F of x is equal to x plus 3 times x minus 2 times x plus 2. That means that my zeros, I have 1 at negative 3, 1 at positive 2, and 1 at negative 2. I look at my exponents. They are all through because all of them just have an exponent of 1. So I'm going to put these on my x-axis. Okay, I have 1 at negative 3, 1 at negative 2, 1 at positive 2. I need to think about my end behavior. I have a third degree positive. Third degree positive should look like this. That means the left side goes to negative infinity, the right side goes to positive infinity. In other words, I'm going to have an arrow pointing down here, and I'm going to have an arrow pointing up here. It goes through all of them, so I just need to now connect my dots. So I'm going to go through, 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 and up. Now, a lot of the ones that we've had so far have had x-intercepts at 0. This one, actually, we can find the x-intercept. It's already right there in standard form. So, you know, my graph wasn't long enough, wasn't tall enough, but that x-intercept should be at negative 12. Now, I didn't have space to do it, so don't worry about it, because I've been saying I don't care how high or low these bumps go, but I just want you to recognize that that is a possibility. Okay, last problem. This problem is different still, because as I look at this, I can't factor it. There's no way to factor this. If there's no way to factor it, what do you do? Well, it's a quadratic. If there's no way to factor it and it's a quadratic, we have to do the quadratic formula. Okay, so for my quadratic formula, x is the opposite of b, plus or minus the square root, b squared minus 4 times a times c, all over 2a. I need to go to my calculator and plug that in. Okay, So if you don't remember how to use your calculator, remember that you go to the alpha y equals to give your fraction. You hit enter there to get your fraction bar. Now you can just plug your stuff in. So go ahead and plug those in. One thing that you need to know about your calculator is that the minus button and the negative button are different buttons. So for that -8, use the negative button down here. Don't use the minus button. And on the bottom, we know it's 2 times a, which is in this case 12. Okay, so we get our answer here. And then remember, you can arrow up. So I'm going to go over here. I'm going to arrow up and highlight what I need. And if I hit enter, it pastes it. And then I can arrow over and get into where I need to be and change that minus to a plus, or excuse me, change the plus to a minus. And so I'm going to hit minus here, and then I hit enter, and I get my new answer. So the two intercepts are 1.24 and -1.07. I'm going to go back to my paper and write that down. Okay, so where the space where it says factored form, it can't be factored, so I wrote that down. Use the quadratic formula instead. I wrote down my zeros because I did this and I came up with those two answers. So those are my two x-intercepts. I need to think about my end behavior. Okay, it's a second power, it's positive, that's going to be a parabola. Okay, so it's the same, I mean, we've been graphing parabolas before, but we're just kind of doing it in a different context, but it's the same parabola stuff we were doing before. We have one at -1.07, so maybe right there. Another one at +1.24, so maybe right there. Both of them are through because there's not any bounces or anything. And then the end behavior looks like this. It's just a basic parabola. It's going to look like this. And once again, our y-intercept was -8. Of course, I couldn't count to -8. My graph isn't long enough, but that's where it technically would be. Okay, so then my end behavior, I need to fill in these blanks, is positive infinity on both. Okay, we went through a lot of graphs in this video. In the next video, we'll go over the back side. But if you're unsure on how I did some of these, bring your questions to class. Write down your questions, maybe down here at the bottom or at the top somewhere. What are your questions that you need to ask? Okay, bring those questions to class so I can answer those questions.